you guys make the flashcards?
Yes.
No? Alright, well, we are beginning this, okay? We had a double bond, yes? And to this double bond, we added HBr or HCl in a reaction called hydrohalogenation, yes?
Yep.
Or addition of HX to an alkene. Okay? The addition to this was what? What did it produce? It produced an alkyl halide, yes? It produced an alkyl halide. So here's an alkene. And here is an alkyl halide. And then we did addition of an alkene. With Br2, and what did this give us? Hello? It gave us, yes, it's anti,
Yeah.
but just the product. What did it give us? It gave us a vicinal dihalide. Okay? And now the mechanism of this is regioselective, yes?
Yes.
This takes precedent with something called Markovnikov addition, yes? Now, did we talk about stereochemistry of this reaction, or we just
No.
talk about stereochemistry? No. So let's do some stereochemistry then. Here is the double bond with hydrogens on it. Let's put a CH3 here. And let's put here we got HBr to this. So you don't have time to write stuff down? Do you ever write stuff down or no?
Yeah, but I mean, you got the. Let's see the best note taker that I know, so I just copy from
So that works out for you.
Yeah.
Okay, so I'm going to tell you what the problem with this will be. Okay? The mechanism from last week, which I kind of mentioned, but I didn't draw them. I thought of not drawing them, but I rethought the strategy. That hydrogen is going to get pulled off. So that double bond or that pi bond is going to attack that H because this is a delta positive while this is a delta negative, yes? The hydrogens are going to go to one of these carbons. Let's say that the hydrogen goes to this carbon here. Yes, and this is going to be CH2, CH3 with the H. What type of charge is this carbon going to have here? Well, that is going to have a positive charge. This carbon is what geometry?
Trigonoplanar?
Trigonoplanar. So this is going to look like this. And this I showed last week too, yes? But I didn't show you that the attack can be either from the top or from the bottom. I did show you that too, but I didn't tell you. So the BR can either attack there or attack through the bottom. Show me, if it attacks through the top, what structure are you going to get? If this is what happens, if the bromine attacked from the top, what do you get? You get something that looks like this with a new bond, which I'm going to draw like that. The new bond will be the Br, and if it attacks through the bottom, what are you going to get? If it attacks through the bottom, you are going to get this. This is the BR. And that. Yes or no? What do they look of each other? They are enantiomers. So, if the reaction, for example, this reaction here, what do you have on this side?
Nothing.
On this side, you're going to have CH2, CH3, yes?
Mm-hmm.
And on this side here, you're going to have a what? CH2, CH3. So this is not going to have, so here is CH2, CH3, and here is CH2, CH3. Are these going to have, are these chiral to begin with? Are these chiral?
No.
They're not chiral because
We have
it has two of the same groups, okay? But if these are not two of the same groups and they are different, so this CH2 was where there? It's here on the top, yes? So when you draw this, where is that going to be? Towards the back. And whatever it's here will be towards the front. And whatever this is going to stay on that plane. And so this will be the hydrogen. They are enantiomers of each other. And since there is no reason why, since there is no reason why this attack is better than this one, because this is flat, both of them take place. And the result is, if it is chiral, will be a racemic mixture. So when you look at the carbocation, if you can get a racemic mixture, you have to draw R and S. The science complex across the lake. You ran all the way here, and now you got to keep running. Huh? It did that on purpose. You can go through this stairs here. I think she has Okay, let's do one and you tell me what you think you're going to get. Okay, you give me the product. That's the way to represent Mr. Wade. Damn right.
Walker won the game.
You like Walker now?
Oh, no. I think it's a different story. But if it really wasn't for him, we would have won that game. Listen.
And how about the rest of
He
the
just got
80
the-
points people shot?
Listen.
What do you mean? He missed 7 shots.
Okay, yeah, but he made it where
And then he missed another 4 after those 2 threes.
Okay, but he got it into overtime. He stretched out those 47
And
seconds.
if we would have made him before, we didn't need an overtime.
Oh, no.
I've already explained to you what if, yes?
You're such a hater. We won. Like,
Oh, I'm happy we won.
yeah, me too.
Okay, first of all, when you add this goes through the formation of what? Carbocation. That's what everybody has to remember. What type of addition is this?
Markovnikov.
So this is Markovnikov, and it goes through the formation of a carbocation.
Mm-hmm.
Every time it goes through the formation of a carbocation is flat. Yes or no?
Yes,
It's
me too.
planar.
Yeah.
You can have an attack from the top or from the bottom, which means that if the new carbon that has been formed here, that is sp3 hybridized, has 4 different groups, it will be chiral. And you have to draw both enantiomers. Is that clear?
Mm-hmm.
Hello? Why Why are you guys staring over there? You haven't gotten over that? So here's what it is. Where is this hydrogen going to add? To this carbon or to that carbon?
That one.
To the one on the right.
This one?
No, to the one on the
To
right.
this one.
Yeah.
Kornikov addition says that the hydrogen will add to the carbon with more
Hydrogen.
hydrogens on it.
Yeah.
So that is going to be a CH3. You agree?
Mm-hmm.
All right. If I draw this carbon going like that towards the back, and I draw this hydrogen coming towards the front, here in the back it will be CH2, CH3, and this will be hydrogen. Which one is the carbocation? The carbocation is this one,
Yeah.
and the orbital looks like this. Yes or no?
Mm-hmm.
The Cl will either add from the top or from the bottom. So if it adds through here, Cl minus, and of course this is not a mechanism, I'm just showing you here what this is doing. You got lost? You had never been to building 1? Huh? All right. So if that happens, why don't you draw them? I'm doing everything here. What are you guys doing? Don't sit far. Don't sit in the back of the auditorium. Here you go. And determine R and S.
If you don't say do the mechanism, we just write the answer.
Yeah, if I don't say do the mechanism, then just write the answer. But I am explaining to you what the answer is, okay? You don't have to draw this on the test, but if you do, it's okay with me. So this bond is here, yes or no? If it attacks through the top, the other bond is going to be towards the top, yes or no?
Mm-hmm.
This here is CH3. This has that bond that was going towards the back,
Uh-huh.
and now this. Is that the way you are used to drawing these enantiomers? Yes, they are. What was here? CH2, CH3, and here is a hydrogen. If the attack is through the bottom, it's going to look like this.
Yeah.
This is the Cl, and this is the CH3.
CH3, CH2.
That's still going that way.
Uh-huh.
This is still going this way. What's on the top is still what's on the top, CH2,
Mm-hmm.
CH3, and what's down here is H. Yes or no?
That's S. And that one is.
Hello?
I'm confused as to why, when it's attacking from the bottom, why you wouldn't move the wedge to the Cl and then the dash to the H and then the CH3, CH2 with it.
Move the wedge
Like,
to the
can you, yeah,
That's S and R.
so I get the top, right, but from the bottom, it kind of like pushed everything else clockwise.
It didn't push anything else. This was on the top. That's on the top. This is still on the top, yes? That was on the bottom. Still on the bottom, of course.
Oh, you just added an extra bottom?
Yeah, you either draw this.
On the top or the
Guys,
bottom?
is this the same thing, yes or no?
Yes.
Yes.
Is that the same thing as that?
Mm-hmm.
Or am I imagining things? It's the same. But if it attacks from the bottom, there is a bond there. If it attacks from the top, if it attacks from the top, there's a bond there. If it attacks from the bottom, there's a bond here. Find R and S. You can what?
One, 2, 3.
Sometimes we're not ready, we just throw it
S
into
and
it.
R.
Okay.
That's
Tell me,
S.
what's, Is this the first priority? First priority? This is second priority? This is not the second priority, this is the second, and this is the third.
Yeah, okay.
The rotation appears to me is, what's that?
S.
That's R, but that's
What do you
R.
mean is R?
That's S right there.
That rotation is S.
S, but you're gonna go R.
Wait.
This rotation is S, but the hydrogen,
No, that's S, but it's
the
R.
hydrogen is in the front. So it's not how it looks, it is
It's R.
actually R.
Thank you.
So how come he said we were wrong?
How come I said what?
How come he said it was an R in the beginning?
You didn't say
I
that.
asked you a question. I said this rotation is what? That's not R, is it?
No.
Okay.
The chemical is R, but that rotation is not R. I asked you, what is this? And you have to say it's S. But it's not S, because this is in the front. How about this one?
It would be S. Opposite of R.
This
S.
is,
S.
how do you know it's the opposite? We gotta do it, no?
Yeah. It's 1, 2, 3.
And this is 3.
But
So
aren't
this
they,
is,
but aren't they enantiomers? So if one is R, then the other one must be S.
yeah, but we are doing the little picture, guys. To show, yes, they are R and S. So this one is doing what? This is,
R.
R.
what we have drawn here is R,
Yeah.
but it's not R because the hydrogen is in
In
the
the
front.
front.
It is actually S.
S.
Would you like to see us do it like that on the test?
Yeah, like this would be nice.
Okay. I'll show you that we understand that it was one just to reverse.
Exactly.
Okay.
This is the way in which I know you guys understand the topic very well. The other way of doing it is understand that this is going to be Markovnikov addition. And because you are going to produce this chiral center here, you can go like this. And then just draw the enantiomers, because you know it's going to give you enantiomers, yes? You can just draw it like this. And then you can put a Cl here, and the CH3 there, and then you draw the other one, in which you change one of the groups, yes?
Yeah.
And you can draw this like that, okay? This is fine. That really shows me you know what the intermediate is and the rest of it. And this is okay. And this and that is the same thing, yes? If you look at R and S here, one is R and the other one is S. Because there is 50% chance the attack is from the bottom and the attack is from the top. This will give you 50% R and 50% S. This is called a racemic
Mixture.
So you always think about if it goes through the formation of a carbon cation, because the carbon cation is planar, you are going to get a racemic mixture. Is that clear? So in the future, if the carbocation is attacked by a nucleophile, I don't have to explain to you again that this carbocation will get attacked from both sides, yes?
Yes.
All right. I bet money this question is going to be on the test.
Wait, Professor,
This?
Yes. Now,
so can we leave the hydrogen like that and then show you that we know that it was supposed to be S but it's R, or do you want us to show that the hydrogen is supposed to be in the back?
if you want to redraw it with the hydrogen in the back, it's okay. But we didn't have to do it for this one because it's in the front. Guys, remember, if the hydrogen is either in the back or in the front, we're not going to redraw this, yes? We only redraw it if the hydrogen is either here or here.
Right.
Yes? I mean, you can redraw it if you want, it's fine.
Astonishing, breathtaking.
This here is The mechanism for, no, this is not hydrogen. This is halogenation. Okay? Or addition of Br or,
Bromonium.
no, bromonium is an intermediate, okay? The
Is that
addition
what it
of,
goes through?
what?
Is that what it goes through?
Yes. Of H2 to the